Alright, so here we are back with our word problems. In this second problem, again, it gives you the perimeter, and it tells you the perimeter is 6x squared plus 14x, and this is for her backyard. I know it doesn't state the shape, but we'll assume the shape is a rectangle. It also tells us that the length of her backyard is 2x squared plus 3x minus 7 feet, and we want to find the width. Okay, so guys, I would like for you to go ahead and pause the video and set up a picture for this problem and label the things that we know and see if you can solve the problem. Okay, so hopefully you've paused the video. If not, please do that. And if you have started the problem, hopefully you started with a picture. Okay, so if this is her backyard, again, we know the perimeter is this, so just like in number 1, this is something that we're going to look back at, because this is how many x squareds and this is how many x's there need to be around all 4 sides of our shape. We also were given that the length is 2x squared plus 3x minus 7. It's totally okay if you considered the left and right sides as lengths. Okay, that doesn't matter. Since I'm considering the top to be the length, I know that the bottom would be the exact same. So I'm going to label that as well. Okay? Now, just like in the previous problem, I'm going to take inventory of what I already have. So I already know that I have 2x squareds and 2x squared. So that's a total of 4x squareds. In my perimeter, I need a total of 6x squareds. So I need 2 more x squareds. And because each of the widths are equal, I need to divvy those up evenly and put 1x squared on each side. Okay, you can write the 1 in front if that helps you, but it's not needed. Okay, so overall we have 2, 4, 5, 6x squareds, and now we know that part of our perimeter is satisfied. Okay, the next thing we need to look at is how many x's we need total in our perimeter. We need 14 x's. If we take inventory of what we already have, we have 3 x's and 3 x's, so that's a total of 6 x's. We need 8 more. Okay, and those 8 x's need to be divvied up evenly on our 2 widths. So I'm going to take those 8 x's that we need and put 4 x's over here and 4 x's over here. Okay, that will give me a total of 6 x's on the lengths plus 8, which would give me a total of 14 x's. All right, now it seems like we've satisfied the perimeter already, but if you notice, we have some terms, some constant terms, that are extra. I'm going to go back and put this in orange just so we know we've already included our x squareds. But what we have left is our -7 in our length on the top and the bottom. That's a total of -14. Okay? But in our perimeter, we have a total of 0 when it comes to constants. So I have a -14 and I need that to become 0. So I need to add 14. So to do that, I'm going to divvy up that 14 evenly on each width. So I'm going to have plus 7 on each side. That way I have 7 and 7, 14, minus 14 here, which all comes out to 0 in my perimeter. Okay? And now I know that my final answer is right here. This is my width, x squared plus 4x plus 7, which is exactly what I was asked to find. All right. Now keep in mind, this is just one way you could have done this. You could have also done it in a different way. You could have maybe added these together and subtracted it from this and then divided by 2. Most of the time my students find that to be a little bit more complicated, and so usually this is the method they prefer. Okay, for number 3, here is a shaded area problem, and it's basically telling us that the area of our square is this, and the area of our rectangle is this. And we want to find the shaded region. Okay? So anytime we do a shaded region problem, you need to remember that to get the shaded region, we have to take the large area, which would be this entire square, and subtract or take out the small area, which is that rectangle. Okay? And since they already provided us the area of the large square, we can just write that down here. 4x squared plus 4x plus 1. And we're going to subtract that, or we're going to take away the rectangle area. Make sure to put that in parentheses. X squared minus 5x plus 6. Okay? Remember, we have to put this in parentheses because we have to subtract each of these, which is like distributing in the -1. Go ahead and pause the video and see if you can finish this problem. All right, if you are rejoining us, once you distributed in the -1, you should have gotten -x squared plus 5x minus 6. And then these three terms would come down unchanged. And then you would have combined your x squareds. 4x squared minus 1x squared is 3x squared. 4x plus 5x is 9x. And 1 minus 6 is -5. Okay, and so this would equal the shaded area. All right, if you look ahead at number 4, number 4 and number 5 are a little bit different because they're asking you to calculate the area. It's not provided for you. And so we'll be using multiplying instead of adding and subtracting. The area of a triangle is given to you here. It's the base times the height divided by 2. This is the base. And this vertical piece here that's perpendicular to the base is the height. Perpendicular just means it creates a right angle with it. So to find the area, the first thing we have to do is we have to multiply base times height. So go ahead and set up your multiplication problem. 2x minus 6 times x plus 3. Now if you recall, you could make an area model for this and multiply that way, or you could distribute the 2x in to the second parentheses and then the -6 in. Choose whatever way you want, pause the video, and then return. If you're returning, you should have a product. It should be 2x squared. Let's see, that'd be 6x minus 6x. So you'd have no x's, and then you'd have -18. Okay, so that's the product of the base times the height. Then of course it says in the formula we divide by 2. So we divide that by 2. Each term gets divided by 2, leaving you with 1x squared minus 9. And that would be the area of your triangle. All right, lastly, number 5 is another shaded region problem. Okay, and again, you are going to want to take the large area and subtract the small area. Okay, so the large area means that you're going to take length times width of the large rectangle. So that would be 2x plus 9 times x plus 6. And then you're going to subtract the area of the smaller rectangle. Again, length times width would be x minus 5 times x minus 3. Go ahead and pause the video and find the product of each one. Alright, so hopefully you have tried the problem on your own. This is what you should have gotten for this product. 2x squared plus 12x plus 9x, that would be 21x plus 54. Minus, on this one, be sure to put this final product in parentheses. This would be x squared minus 8x plus 15. Okay, so now you're ready, now that you have the two areas, you're ready to do the subtraction. Remember again, this is like a -1 that's going to get distributed in. Go ahead and pause the video and see if you can finish the problem. Alright, if you're joining us again, this is what you should have gotten when you distributed the negative. Again, each of these just change signs. Then you could bring down the rest of this problem and combine like terms. 2x squared minus 1x squared is x squared. 21x and 8x is 29x. And then 54 minus 15 is 39. Okay, and so this is your answer for the area of the shaded region.